value y. Step 2, we're going to interchange x and y. We talked about how we reverse x and y. Interchange is another word for that. In other words, replace every x by a y and every y by an x. They switch places. Our third step is to solve for y. And our last step is to rewrite our equation with the inverse notation. In this case, f to the -1 of x. That means inverse of a function, the inverse of function f. So when we take a look at this first one, step 1, replace f of x with y. Step 2, switch the x and the y, interchange the x and the y. X goes where y went, y goes where x went. Nothing else moves. Step 3, solve for y. So we're going to subtract 3 from both sides. And we get x minus 3 equals -2y. And then to divide, or then to solve for y, we have to divide. It's -2 multiplied by y. So our opposite operation is to divide by the -2. We end up with y equals x over -2. Negative divided by negative is positive 3 over 2. And by the way, just in case you don't know, when there's no number written in front of the x, it's a 1. That seems to be causing some people some trouble. So I do want to show it, even though my answer was fine beforehand. This could also be written as -1/2 x plus 3/2. And again, in inverse notation, it's f to the -1 of x. Some really good steps to follow when we convert here. And we didn't have to graph on these today, but the process is going to be the same each time. When we start, this time we have g of x equals -1/5 x minus 1. Well, g of x can be replaced with y. Step 1. Step 2, switch, interchange the x and y. X goes where the y went, y goes where the x went. Nothing else changes. Step 3, we solve for y. So in order to do that, let's add 1 to both sides. We get x plus 1 equals -1/5 y. Well, we've got a fraction in front of here, and sometimes that causes people trouble. But an easier way to solve this, especially if you don't have a calculator, it is to multiply this side of the equation by 5, which is from the denominator. And if we multiply the right side of the equation by 5, we also must multiply the left side of the equation by 5. Notice that it's going to be every part of the left side of the equation by 5. It doesn't completely solve our problem, but we get closer here, because 5 divided by 5 is 1. So now what we have on our right side of our equation is negative, if I can write it correctly, we have negative 1y. Again, the 5's canceled out. And on the left side, when we distribute our 5, we end up with 5x plus 5. But what we are in, we're in step 3, which says solve for y. We need to solve. Divide by negative 1. Divide by negative 1. Divide by negative 1. We end up with negative 5x minus 5 equals y. And it depends on your teacher, but usually what I do is I just write the inverse in this step. There's the inverse notation. G to the negative 1 of x equals negative 5x minus 5. Good steps to follow. We started in on Friday on that. We're finishing this part up at least today. H of x. Well, h of x can still be rewritten as y. Our first step second step, switch the x and the y. Interchange the x and the y. X goes where y went. Y goes where x went. Nothing else moves. And we want to solve for y. So now we've seen a problem with a fraction in it. The process is still the same. We don't like that fraction over there on the left side of the equal sign. So let's multiply about the right side of the equation. Let's multiply the right side of the equation by 2, and if we multiply the right side of the equation by 2, we have to multiply the left side of the equation by 2 as well. But what we accomplish when we multiply both sides by that is that those 2's cancel out. 2 divided by 2 is 1. And now what we have left is we have 2x equals 7y plus 18. And remember what we're in the process of doing. We're on step 3. We're in the process of solving for y. So we want to get y by itself. So we'll subtract 18 from both sides. And we get 2x minus 18 equals 7y. And then finally it's 7 times y. Opposite operation is to divide by 7. And we end up with 2x over 7 minus 18 over 7 equals y. And in inverse notation, that's h to the negative 1 of x. So now, let's explore the relationship between the function and its inverse. And when we explore this relationship, we have to go back to our composition to help us do that. We need to figure out, what does f of g of x equals? What does g of f of x equals? And remember, we can write that notation as it is the first way, or we can write it with the open circle. They mean the same thing. So when we're looking at these, it says, given the function, for example 2, given the function f of x equals x plus 5, and g of x equals x minus 5, we need to compose those. So when we compose that, remember we're going to start farthest to the right. So here's g of x. We want to fill in g of x. What does g of x equal? So when we come back here and we look at what g of x equals, we're looking back in the problem, it says g of x equals x minus 5. And we're going to take that value of x minus 5 and we're going to put it back into our f function wherever we see x. So let's take that value and let's replace it back in here for the x. So we get x minus 5, replacing the x, plus the 5. And what does x minus 5 plus 5 equal? Anybody? Not 0. Closer. 1x. Negative 5 plus 5 is 0. And then we still have the x. So now, we're going to go the other direction. We're going to do the same thing. G of f of x. Remember, start farthest to the right. So this time, we're going to fill in f of x. What does f of x equal? So we're going back to our problem. And f of x equals, based on what we're given, x plus 5. And we're going to take that value and we're going to put it back into our function here of the g, which is x minus 5. So in other words, we're going to take this value of x plus 5. We're going to put it back in here for the x. So we end up with x plus 5, replacing that green x, minus 5. And what does x plus 5 minus 5 equal? Anybody? It equals x. So if we look down here, what is the result of both compositions? F of g of x and g of x, what did we get when we finished both times? We got x both times. Let's try another. Same kind of thing. Given our function, f of x equals 1 half x plus 3, and g of x equals 2x minus 6, we want to figure out what is f of g of x. So we're going to start farthest to the right. So we're going to fill in our value of g of x, which is 2x minus 6. And then what we get is we get our f function, which is 1 half x plus 3. We're going to take that value of 2x minus 6, and we're going to replace the x in there. Remember, it's 1 half multiplied by x. So this is going to become 1 half times 2x minus 6 plus 3. We replace the x in our f function with our g, with our output from our g function. We can distribute half of 2. Half of 2 is 1x. Half of 6 is 3, plus the 3. X minus 3 plus 3 gives us x. And 3's are inverses, they cancel out. But we need to do both of them to look at the relationship between a function and its inverse. But now what's going to happen over here is we have g of f of x. Remember, start right. When we look back at our problem, f of x is 1 half x plus 3. We're going to take that value and we're going to put it back into our g function. So that's what we're going to do. 1 half x plus 3. Going to go back in here for the x. So it's going to be 2 times 1/2 x plus 3 minus the 6. Don't forget the minus 6. And we need to distribute again. So it's going to be this times this and this times this. 2 times 1/2 still means half of 2. What's half of 2? 1. So this is 1x. Then 2 times 3 is 6 minus 6. So when we combine like terms here, the 6 minus 6 cancels out, and we're left with 1x, which is the same thing as x. And again, what is the result of both of our compositions? Well, we ended up with x both times. So far, it looks like two functions are inverses if and only if f of g of x equals g of f of x equals x. But let's try one more here to make sure that it is true. And the thing is, you don't have to have inverses, but right now it says, show that the following are inverses. So sometimes the question might be, are they inverses? And then that's what you want to do. You want to show f of g of x equals g of f of x equals x. But it's the same process here. We want to figure out what f of g of x equals. And when we're done with that, then we want to figure out, well, what does g of f of x equal? Each time. Well, we're going to fill in our g of x, which is negative x plus 1 divided by 4. We're starting farthest to the right. We're going to take that value and we're going to put it back into our f function, which is negative 4x plus 1. Be careful with your steps here. We need to make sure to follow our order of operations. So we are going to take this blue value and put it in for our x over here. So now it's going to be negative 4 times negative x plus 1 divided by 4. We replace the x with our output there, plus 1. And here's what's causing a little bit of trouble. Hopefully you know this, but if you don't, we can divide. This is negative 4. Let me do this. Negative 4 divided by 4. Well, negative 4 divided by 4 is negative 1. And we still have what's in this parentheses here. Negative x plus 1. We were able to eliminate the fraction. And then we still have our plus 1 over here. We're trying to get this value to equal x. At least that's what it says in our paper. Let's try one more to make sure. So we're going to distribute. Negative 1 times negative x is positive x. Negative 1 times 1 is negative 1 plus 1. And x minus 1 plus 1 definitely equals x. So let's go the other direction here. G of f of x. Well, it's going to be g. And our f of x is negative 4x plus 1. We're going to take that purple value and put it back into our g function wherever we see x, and we need to be careful. That negative sign sometimes is confusing for people. But we're taking this value of negative 4x plus 1, we're putting it in for x. We still have a negative. Let me do this. We still have a negative. And then we're going to put in the negative 4x plus 1. So we just put that value in for x. We still have the plus 1 divided by 4. Again, follow the order of operations. Don't skip steps. When we follow the order of operations, we need to distribute. Negative times negative is positive. Negative times positive is negative. We have plus 1 divided by 4. Again, don't skip steps. Our next step is that we can combine like terms, and our like terms are the negative 1 and the positive 1. They cancel out to be 0. So now we have 4x divided by 4. And what does 4x divided by 4 equal, Tiffany? 1x. So there again, when we have inverses, f of g of x equals g of x, g of f of x equals x.